Hello, I'm Stef Lermit of the Department of Geoscience and Remote Sensing of Delft University of Technology, and today I'm going to talk to you about the role of Antarctica on sea level rise and how the ice shelves of Antarctica are the gateways to this sea level rise. If we look at the IPCC projections of Antarctica, we see that Antarctica is the largest uncertainty in future sea level projections, with projections that go from contributing to sea level rise to contributing to sea level lowering. And you can see that the spread of the projections is relatively large. Now, if we look at current observations, we see that actually the current mass loss of Antarctica is very close to this upper range of these IPCC projections. It basically means that Antarctica is losing more mass, or close to the upper range of the projected mass loss. Now, this mass loss or these changes have very large regional differences. Here you can see an animation of mass loss from satellite over Antarctica, and you can see that there's areas, for example, the Amundsen Sea embayment, where there's a lot of mass loss, and where there's other regions where Antarctica relatively is gaining mass, and there's more snow falling than there's mass being transported away. Now, to understand these roles, we have to get a good understanding of the processes that happen, and this includes understanding the roles of ice shelves. Ice shelves are the floating part of the ice sheet, and it's basically the ice that comes into contact with the ocean, and they are the gatekeepers. They act as a buffer between the continent and the ocean, and they surround about 75% of Antarctica's continent. And we have to really understand the processes that happen on these ice shelves if we want to understand the role of Antarctica on future sea level. And these processes can be very varied and sometimes very complex. It goes from melting at the bottom due to warm ocean water to melting or at the surface due to atmosphere ice interactions. And recent studies have shown that we start to understand these processes much better, and by changing some of these processes in our models, we can get very large changes in sea level rise contributions. There's a study that shows that if you allow for hydrofracturing and marine ice cliff instability, we can get sea level rises which are much higher than the current IPCC projections. So understanding these processes is crucial, and this includes understanding this ice-atmosphere interaction. And to show you its importance, I'm going to show you this satellite image of Larsen B ice shelf. It's 2002, and this ice shelf collapsed on a relatively short period. And if you look in detail in this image, you see that there's all these blue dots on the ice shelf. These are actual lakes ponding on the ice shelf, and they're believed to play a major role in the collapse of this ice shelf, which happened over a period of a couple of weeks, where we lost a very large piece of the ice shelf, resulting in a glacier speed up and a subsequent sea level rise acceleration. Now, where this meltwater was long believed to be a rarity, we start to realize that this meltwater is much more widespread across a lot of ice shelves in Antarctica, and that it has been there on some of these locations already for a very long period of time. So it is very important to understand what happens with this water. Does it accumulate in lakes? How does it drain? For example, in this video, you see an interannual satellite composite where you basically see how the water accumulates in lakes and then all of a sudden drains to the bed. And so understanding this water and what actually happens to it is a very important aspect if we want to understand what will happen with the ice shelves of Antarctica in the future. Because there's basically two scenarios that the water can have. It can have a good influence, it can run off and therefore not accumulate or result in this hydrofracturing, or it can follow a bad scenario where it forms ponding lakes that due to their pressure and where the water accumulates due to their pressure destabilize the ice shelf, or accumulating crevasses resulting in this hydrofracturing effect. So understanding the role of water is very important. Here you see a video of our team in 2016 where we visited one of these water systems on the Robodoin ice shelf. And you see that the water accumulates in rivers, flows across the ice shelf, and eventually drains in what we call a moulin, so basically where the water, as a waterfall, goes down the surface towards the ocean. So understanding this role and how it actually damages the ice shelf is very, very important. Now, where does this water come from? We've shown that there exists a type of microclimate on the grounding lines, there where the grounded ice and the ice shelf are combined, where there's a warm microclimate with temperatures that are up to 3 degrees warmer than their surroundings. And in these warm microclimate, which is the result of the wind, that is the katabatic winds that blow downstream and result in a vertical mixing of the atmosphere, you have a warm area and at the same time a dark area. The wind blows away the snow and exposes darker ice, and due to the fact that you have darker ice, you have more solar radiation absorption. And you can see this again here. This is the albedo map of Antarctica from satellites, that you very often have these relatively dark albedos always at the edges of the grounding lines of the ice shelves. And so by combining warm and dark, you get surface melt. And some of this surface melt is very obvious and results in these lakes and rivers. Some of the water is much less obvious as it accumulates below the surface, or it accumulates in lakes that have a frozen lid. As you can see here in this picture, 2 satellite pictures, we see there's 2 lakes which are not always that easy to discriminate because they're covered by a frozen lid. And this is also obvious if you go into the field. Here you see again a video of us where we are studying such a lake and where we lowered a camera in one of these lakes. And you see the camera going down, penetrating the ice with some water already in the borehole, where you can see clearly the bubbles. And after 4 meters of ice, you all of a sudden reach a large lake, which is such a surface lake, which is not obvious from the surface, but could have important implications for the stability of the region in total. So as a conclusion, I want to wrap up again to say that Antarctica is one of the main uncertainties in future sea level rise projections. And ice shelves are key in this uncertainty. We have to very well understand the role of ice shelves if we want to understand the role of Antarctica on future sea level. And therefore, we have to understand the role of meltwater, because meltwater systems like these rivers and these lakes can have an important implication toward future sea level rise. Thank you very much.